an SQL-based data analysis platform using homomorphic encryption, and it's Jae Lee from Desilo. Welcome. You have 25 minutes.
All right, thank you, everyone. Hello, everyone. My name is Jae Lee. I'm currently a business development lead at Desilo, and I'm representing our work here. Thanks for hosting us. I do want to mention that my colleague was supposed to be here to present this amazing work. She unfortunately couldn't make it, so you're stuck with me, but hopefully this will still be useful for everyone. So at Desilo, we fully believe in having a strong PT full stack solution, which harnesses not only the underlying subcomponents such as cryptographic engines, but also really having a strong focus towards building practical applications and services, which are actually very critical for accomplishing our core mission, which is to reshape the future of data collaboration. And so in recent years, there's been a number of interesting trends that have to do with data growth. So first, on the far left, data obviously is exploding. Data volume is obviously off the charts. Number two, in the middle, the need for data analytics, so data consumption is also exploding. But unfortunately, number three, on the far right here, the rate of growth for data broker markets is actually not as fast growing as the other two. And so there's a number of factors, obviously, that you have to consider to evaluate the full situation. However, it is very clear that the amount of data transactions or data growth or data brokerage isn't growing quite as fast as some of these other, the exploding demand for data, the data volume, and also for data analytics. And so if we look at a couple examples here, so one example that we can think of is, let's say that you are doing in the medical field, you either are trying to understand, let's say, for example, like the cancer mortality rate for a particular cancer for a particular patient group. Obviously, you want to have a lot of data at your disposal to be able to combine and understand the actual effects and correlations that you're trying to study. And this could be used, seen on the far right here, for either cancer research itself or for policymaking. So there's many different uses. But nonetheless, whatever it is, you do want to pull data from multiple sources. And so on the far left there, for example, you could think of easily, you have like clinical data from your hospital or your institution has treated a lot of patients over the years. They have a lot of patient history and patient data, and so you're able to actually pull from that. In Korea, though, there's a lot of laws or a lot of different barriers that actually prevent you from freely sharing that data, even within your own hospital, so within the departments. So for example, let's say one patient comes in, is treated for a certain type of disease, but they've also been attending this hospital and been treated for other things in other departments. You still have to go through a lot of different hoops to actually get data from other departments as well. So there's also issues there. But even with that, let's say, for example, that the patient is treated, is cured, and after 5 years, he or she leaves the hospital. Even if that patient came in and actually consented with all his or her medical history, once the patient leaves, now you have no idea how that patient fares over the next 5 or 10 years after that. And so there is interest in terms of trying to monitor how the patients evolve and how their lifestyle or different things happen after they are actually properly treated and cured of a disease, for example. And also, lastly, there's also a bunch of data collected by the government. And so the National Bureau of Statistics or the National Health Institute, for example, in Korea, each department has their own set of data that is actually very useful. And so if you're trying to correlate different symptoms and different causes across the border, you really want to be able to pull data from all these different sources. And obviously, something like this doesn't really work that well in practice because there is, like I said, a lot of different issues that you have to try to solve to get data and pull it from these multiple sources. And so, in essence, what we have is a situation where you're trying to pull multiple data sets, combine the data somehow, do something useful, and extract useful information from that. And that could be, you could have multiple different people doing different types of analysis from that. But in essence, you are relying on the credibility or the trustworthiness of the actual platform itself, because the data is going to be exposed to someone along that chain. And so that inherently exposes risk for data exposure, and that's something that you cannot inherently get around. And also because of that, especially if you have a lot of sensitive data or if you have data that you perceive to be very sensitive, it doesn't really matter whether the data actually is sensitive or not, but if you perceive that your data is valuable and sensitive, then that creates a problem because many people are unwilling, or many organizations are unwilling to actually onboard their data, even onto trusted platforms as we know of it. So this sort of structure as it is not really scalable for a true open data exchange. And so what is our solution to this? Obviously, we believe that homomorphic encryption can play a key role in this. And obviously, some of the concepts here is actually not new. This is very well circulated. But you can think of, so our solution is to sort of have a data platform that actually promotes a very open and secure data ecosystem. And to do that, obviously, in the middle here, we have something, a data clean room type system where everything stays encrypted while you're doing computation, utilizing the full power of homomorphic encryption. So in the middle here, data comes in encrypted, data stays encrypted, you compute, you'll do all sorts of operations, and data goes out encrypted. And so the data is concealed throughout the entire chain. Example on the far right here, you can imagine that same medical researcher, he's trying to get access to a wealth of data. So he puts in a request, sends the request over through our system. The system pulls in data from multiple sources, collects the data, does some statistics, some analysis, sends the data back, but it sends it back in a encrypted form. And obviously, by the consent of all the data owners that are involved, this final result, which is in many cases might be just a single number or a group of numbers or a column of numbers or something that actually is an aggregate statistical number, is then decrypted based on approval by the data owners, which could be automated or done manually. And so you have an entire system that is built around, that is secure by design because you are relying on the very fabrics of what homomorphic encryption enables, which is that you do not have to share the actual content of your data while doing something useful with it. And so data data moves along this chain, data stays safe, and still you're able to extract useful information from it. So this flow has built-in protection. In practice, though, how we actually implement it, actually you have to still be able to separate it out into 3 different components. And so I mentioned that our product is called Desilo Data Clean Room, but it's actually implemented in 3 different chunks, so to speak. And so right in the middle here is sort of the core of it, whereas you're doing most of your homomorphic encryption computation. And so a lot of this, there's a lot of parallel computation going on here, a lot of distributed computing as well. And so that's your main sort of source for computing. On the far right, again, your analyst or whoever's consuming your data is then trying to make certain requests, figure out what kind of data sets you have, and then be able to extract information from that. And so in this particular talk today, we're going to be talking about a SQL query-based approach. Obviously, there's many things that you can do around this, and so we have variants that have departed from a SQL-based approach in more recent months. And so you could do different types of visualizations, different types of interfaces to interact with that. But the core of it still stays the same. Someone has to put in a request, data then gets sent out and encrypted all the way, gets back, and then you sort of have to do some type of either visualization on it or something to make it useful for the user. And then on the far left here, we have an entire system that is actually devoted for the data providers. And I think this is a very key point because, again, your entire chain is actually separated. So everything that's done on the far left here is really under the control of the data owners. And so the data owners get to upload their data. They get to make sure that it stays encrypted, and everything that has to do with that stays within that sort of green box on the far left there. And so there are key issues that you have to resolve here, which is number one, obviously, is key management, which is not which is contained within that left box over there and does not spill over to these other areas. And then also you have to give data owners really a lot of fine control over how their data is going to be used or consumed down the chain. And so that could involve, I don't want my data to be sent to certain different specific parties, for example. I want my data to have certain properties that are concealed, et cetera, and the list goes on. So you could actually imagine a system would have a long list of fine control for the data owners that gives additional security for them. So this is sort of the crux of the system here. There's obviously a few benefits from this, and the benefits are actually quite clear, but they're quite different depending on which side you're on. So if you're on the data provider side versus the data analyst side, there are some very key differences. I'll go through a little bit each of these in the next few slides. I do believe we have a video demo at the end, so that'll give you kind of a feel for how to walk through how the system actually works in practice, and we'll walk through that. But here's just a few screenshots to kind of show you what it looks like as we sort of step through it. So first, for the data providers, first of all, the data providers and the data analysts, obviously they would have to log into a different system because, again, the systems are they are separated systems that are managed separately. And so for the data provider side, you could either imagine having this that's either installed in whatever environment the data providers feel comfortable with. So if they are using a certain cloud service provider, you could imagine having our solution for the data provider side installed in that environment. And so you would minimize data movement, but you would also have a secure system that's contained, that's only visible by the data providers. You could also do this on premise as well. And so there's different approaches. But nonetheless, the key idea again here is that this system stays on the data provider side where they know that their data is, and so they would upload their data through the system, and there's a simple interface to do that. Currently, at the moment, we only are able to upload CSV files, but we noticed that a lot of data providers, at least that we've talked to, are still very hesitant and reluctant to actually share a lot of their data. So they do have to do some sort of process to either filter out a few things or do some type of post-processing. So they end up anyway exporting that data into a certain data type file format anyway. And so currently, as of now, CSV is sufficient for most of our applications that we've been looking at. Secondly, once the data is uploaded though, like the data, again, like I said, the data provider is able to control a lot of different aspects around their own data set. And so one example that's shown here is, again, this is a screenshot. There's a couple of things here, but I'll just highlight the one in the middle here, which is the large green box dotted here. So this is something that's called a minimum aggregation threshold that the data owners are able to set. So for example, you could imagine a case where you have like a 10 million user database with very sensitive information. The analyst sitting on the other side decides to come up with a very smart query. He basically has a very narrow filter, adds in a lot of conditions, and then tries to get like a single data point, for example. And so obviously, if that's the case, then you are at risk of exposing a single data point of whatever that the analyst has requested. And obviously, you want to guard against that. So there is a thing called a minimum aggregation threshold, which, because in our application, we are mostly looking at statistical analyses. So you would have to guarantee that there is at least like a minimum set of number of results from the query that has been sent. And so if, for example, you set it to a minimum of 10, then you need at least 10 data points to actually aggregate that and return a result. And so otherwise, it will just return nothing. And so by this provides another additional layer of security for the data owners, for preventing singling out specific data points that could be exposed. And so there's a number of different other data governance issues that you also have to be aware of. But with all of these features in, what this really provides for is a mechanism to be able to give basically the power back to the data owners. And by that in turn gives assurance to the data owners that knowing that their data is secure and stays safe throughout the entire command chain as well. And we've been talking to, I guess, about a handful of different data providers, and almost, I say almost because there are some exceptions to this, but almost all of them start this journey with the point of, hey, I have excess data that's just lying around. I want to monetize it. How can we do that? And so there really isn't a market, or even if there is a market, there isn't an easy way to sort of get that data out into the open market. And so what we've realized is that from the data provider side, there is actually a very clear need for data owners to want to be able to monetize that. And having a secure system like this not only provides assurance, but also just security and data prevention is built into it. And so this gives assurance that their data is set, and you also don't have to worry about your data being recopied, because in many cases, when data is sold, you actually are selling the raw data as it is. And obviously, as time goes on, it gets outdated and there's very less use of it, but still, there's no way of actually preventing that from being recopied or resold at some point later down. And so this gives full access to and full control back to the data owners, which again is a good way of actually bringing out the data owners into this sort of open data ecosystem for data exchange. Now switching sides, going to looking at data analysts. Again, the user interface, it looks very similar. We use sort of similar color schemes, but again, you're kind of logging into a different system with a different login and password. And so the data analyst would again log in. For the panels that you're seeing for the data analysts look quite different because here you don't really have much access to the actual data behind it. You only have access to what you're able to actually query, what kind of insights you're able to get from it. And so in this case, for this particular scenario, there's some information about the data because you do still need to know a very minimum like meta information about what kind of data sets that you have access to. And so this could mean different data columns that are in there, et cetera, et cetera. And also if the data owner has set a minimum aggregation threshold, then you're able to see that information as well. So there's some information relayed over to the data analyst. And again, like I mentioned, for this particular product, we're using SQL queries to actually as the main user interface. And so here, you could build your SQL query either just by directly typing it into the system, but also you can do like a form builder here that we have. And so on this particular slide here, we're showing that there is a SQL sort of form builder, and then on the far right here, there's a number of different options that you can choose from. You can choose from different data sets that you have that you're granted access to. Also, depending on the type of analysis that you're doing, you can actually list up a number of different statistical values that are of interest. This is not an exhaustive list. I think the demo actually shows a more comprehensive list, but there's different types of analysis. We also do multiple linear regression. There's also different types of analysis that you can do. So again, you can choose from the list, select your query, and then send it off. And then lastly, I do want to mention that an additional advantage for the data analyst is that this really shortens the time down for them to actually do meaningful research. So for example, in the use case that I mentioned earlier about doing medical research on cancer and cancer mortality rate, we've actually had a partner with a cancer institute, and he was mentioning about a process where he was given a government grant. It was about like a 1-year grant, I believe. And so, but during that time, he basically had to wait 8 months to actually get approval to actually get the actual data. And this was not from data outside his institute. It was actually data within his own institute. And because there are several barriers that prevent you from actually getting access. And you have to go through a lengthy review process. And it's not just a single round, there's multiple rounds around that. And so, again, that was very painful. And so if you're waiting 8 months to do an analysis that could take only like a few minutes, then that's really painful. And so again, something like this enables you to have quicker access. And so if you're able to onboard more data like this, either within an organization or without and across different organizations, either way, it's a win for everyone. And I'll talk about this a little bit later because, again, this goes back to the idea of like computationally, like homomorphic encryption is actually very heavy, but there are ways to limit that. And if you look at the broader picture of it, 80 days is still a lot better than waiting, a few minutes for a result. The opposite. 80 days is much, far worse than, waiting a few minutes. So it's still acceptable in some cases. Now, going from all of this, but actually doing it, going to practice it, the best practices is actually you still have to worry about a few things here. So number one is obviously data representation, and minimizing error control and actually getting a good handle on it is actually also very important. There are very simple ways to do this, but the main point is that you do need safeguards around this that are built into your system. But obviously this also depends on your use case too, because depending on the data set that you're looking at, some markets have quite different error tolerances for their data or the type of analysis that you're doing, and also for the different use cases that are very different. So in either case, you do want to have some level of control over it and actually keep an eye on it to prevent numerical errors that are going to eventually propagate and pop up. But second is, and the meat of it is really performance. Like, how do you get really good speed on this? And obviously, the first thing is actually do parallel computing. Obviously, there's a huge a big thrust around this as well, either through a lot of different hardware acceleration or in different types of acceleration. But in addition to that, and I think going in tandem with that, you also need to, you can actually do a lot of different engineering tricks around this, because if you look at the entire problem, and I think we've looked at this not only for this example, but for other some of our other projects that we've done internally, is that you don't really necessarily need to have everything encrypted, every computation done in its encrypted state. I mean, so what I mean by that is, if you look at the problem and sort of dissect it, there are some parts of the computation that you could sort of pull out either before or after the computation and do it there. And so again, if you do tricks like this, then it makes much more sense engineering-wise to separate that out, distribute the operation so that you actually get a much more lighter computation for your actual process that's actually causing the main bottlenecks. And so we've done that around some of our work here, and we were able to reduce it. I don't actually have the exact numbers, but there was quite a bit of engineering around that to actually get this to work. And the last one is data governance. And this actually turned out to be quite surprising. This was more important than we actually thought in the beginning, because again, you can get the first two right, but if you don't get the last one right, you don't really have a market, you don't really have a product that's actually usable. And so we noticed that not only do data owners want very strict and very and more control over how their data is being governed and used, they also the governing, the bodies, the different committees within the government, they also want to have to be ensured that you actually have full control over how everything is done. And so I mentioned minimum aggregation threshold. That's one aspect of it, but there's other aspects where, for example, homomorphic encryption alone won't actually solve every issue. And so, for example, you can think of someone querying, sending a query. It's like a 10 million user database. They send in a query, they get 500 results with an average number for a certain, for a certain thing. Maybe it's like average monthly income or something. And then the engineer sits behind, thinks of it, and sends in another query that's very finely tuned to get 501 results, the average of 501 results. Now, if you do that, obviously you can actually infer or back calculate what that additional data point is. And so, again, in that case, you want to have protections against that. And so there are ways to do that by adding either semi-automating or fully automating your query approval process. And there are some interesting stuff around that. We are short on time, so I'll just skip through this. We have a poster down there, so I just recommend you guys check that out. We did put a lot of work into getting multi-GPU scaling and among other things. We do have a few websites on GitHub and also a documentation page, and we have a poster, so please do check that out. I do want to mention that getting the product, getting the customer, getting everyone happy is obviously not enough. This is certainly more true for some cases, and this is actually not true for other cases, because depending on the data set that you're actually working around, you could actually move outside of the realm of regulation and actually do it within your own different companies or parties that are interested. But in the case of healthcare and certain markets, obviously there are very heavy laws around that. And South Korea is actually, I think, it has very strict laws. It's very conservative. And so if it doesn't know what it is, it's probably outlawed by default. And so the approach is that you have to sort of convince everyone that, hey, this is not a problem, this is actually safe. And so there's different loops that you have to go through. And so this was, we got approval by the committee earlier this year. And obviously this is not, this doesn't solve everything, but this is one step towards it, because again, like I said, there's many governing bodies that you have to go through. And if you're actually in the finance sector, for example, this is good, but this is only a starting point. There's other like 2 or 3 other committees that you have to go through to actually get approval. And so again, this is a sort of a long fight, but either way, there are some base laws that other markets or other sectors actually reference to. And so the personal privacy information law is actually very strict. And so if we got, having this first win was actually very critical for us. And we're excited to sort of like move on to that. I do have a demo, but I think we're short of time, so I'll just sort of skip that. Just kind of closing down, there have been a number of events around this. We did try a pilot launch last year to service it and to really see how reliable our service was. And it worked quite well. There's a number of different activities ongoing this year as well. Some of it's still in the making. I didn't put a lot of information about some of our private our companies that we've been partnering with in the private sector, but there's a lot of interesting information there as well. So I'm happy to come find me afterwards. I'd be happy to have a discussion on that as well. In closing, again, we've presented our Desilo Data Cleanroom product, which facilitates secure data flow. And again, here's my contact information. Feel free to find me. We have a poster. Again, come talk to us. Thank you very much.
We have time for questions.
Hi, thanks for the really interesting talk. So with your minimum aggregation threshold, have you thought, so I've got two questions, one's technical, one's kind of business. So the technical one is, with the minimum aggregation threshold, why don't you use differential privacy? So that's the technical question. And then the business question is, you kind of talked at the beginning about like a data market, you know, people want to monetize data. So you've got the technique to kind of enable that, but how do you actually enable the monetization and the market in data in the first place? Because actually, how do you actually kickstart the business? So kind of two questions. Do you want to, either order?
Yeah. So I probably won't have like a clear, satisfactory answer on both of those. But to start off, so you're right. Like differential privacy is obviously the one technique, but we noticed that depending on the data set, some customers don't like adding additional noise to that because it actually skews the actual outcome. And so depending on the data set and depending on the customer, sometimes they just won't use it at all anyway. And so we've looked at it, we've talked to customers, and some of them say, hey, we're not going to use it anyways, so don't bother with it. And so I think there is a use for it in certain applications. Obviously we can do that, but I think this was like a much more easier, like low-hanging fruit that we could do, easily implement in the system. And it kind of gets it done because most of the data queries that you're using, you're just going to be running on like multiple thousands or tens and hundreds of thousands of data anyway. So typically you get around it, and this is sort of like a very baseline minimal sort of a safety mechanism for that. In terms of the business, I think you're right. I think there's still a lot ongoing, and we're still trying to figure that out right now because with the different customers, we have a handful of customers that have sort of promised or are looking at onboarding their data. We have about a couple that have already onboarded their data, but still, how to create a market out of that, I think, is the next step in this journey, and we're still trying to figure that out because, again, there's regulations depending on the different data types. Having a single product doesn't really solve all of that, and so we've looked at different variants of sort of diversifying the product line based on the market segments or different sort of variations on depending on whether it's closed, open, different type of data sets. And so those are all valid questions. If you have great ideas, let me know as well. So I'd be happy to take in that. So thank you.
Thanks for the talk. It's important we bootstrap businesses like this to make the market happen. And since Nigel stole my first question, I'm going to foot stomp that for a second, right? This notion of an aggregation threshold seems a really poor heuristic, right? For a couple of reasons. One, humans who are going to set those thresholds are really bad at assessing risk. Two, if a querier has access to outside data, those thresholds mean nothing anyway. You need a better technology than that. Yeah. Differential privacy is something to look into. It could maybe solve the problem, but it's going to make the FAG computations more complicated. So definitely something you should look at, I think. Second thing is that the imputation, cleaning, schema regularization across data sets, because you have to have access to all the data sets to do that, seems a problem here, especially in health data, because if you look at hospital records from different departments and hospitals, a lot of the data is missing or poorly done, or the units don't make sense. Do you take care of that, or how do you do that homomorphically when you have to do this across multiple data sets?
Yeah, so those are very good questions too. So one caveat for the entire presentation, I think, so we've looked at the main two sources of data that we actually have been trying to onboard. One is healthcare, one is actually finance data. But in healthcare, you're right, because those problems do exist. And one sort of a disclaimer for all of this is that you notice that on my last to last slide, there was a Korean like the yin yang symbol there. That basically means that everything's government sponsored in that domain. And so we're doing it in sort of a very tightly closed and monitored space because, again, the government sort of trusts us, but they sort of don't yet. And so there are very severe limitations around how our product is actually being used. And so again, to actually get this into the fully open market, I think you're right. You have to have other protection mechanisms to do that. But as of now, again, we're running it with a very limited set of features that work for the use cases that we're looking at, and I think that's sufficient for now. But again, building on top of that, that's all future work that we have to look at.
Okay, one final quick technical point. In the clean room picture, you said you're doing join and then processing the query. It sounds like you're doing all that in FHE. It seems like we're seeing more and more applications emerge where we're combining things like multi-party computation in FHE. It may be worth looking at PSI, privacy
Yeah.
intersection, as a way of doing those equijoins, especially if you're doing them pairwise across departments, which often happens.
Yeah.
That might speed things up,
Yeah.
just as an idea.
Yeah, no, yeah, I think that's good. So there's another application that we didn't mention here, which is digital ads, and I think in that space, it's a different market because the data provider and the data analyst side is actually set up differently, and so in that space, actually, we do have considered looking at PSI and other techniques to actually do that, because it's a much simpler approach. It gets the job done, and there are ways to sort of work around that without the overhead of doing something like a elaborate join here. But yeah, that's a good point. Yeah.
Hi, so when you got these government approvals to be like usable for this personal private data, what would you say were their primary concerns, right? Like, because in theory, you could have like some trusted office that people submit queries to and they run it, they have access to all of the data, and conceptually that kind of behaves similar to how an FHE system would work, where you, instead of having encryption, you have some trusted party. So I guess, how is that the like mental model that you believe the regulators are using for understanding your system, or is there some other goal or framework that they have in mind?
Yeah, another good question. So I think it depends on the regulators, the regulating bodies that you're actually talking to, because again, there's a number of different privacy laws, and there's a number of different regulators that you have to end up talking to. But in our case, there's a couple different main bodies that we actually talked to. The PIPC was one of them. But I think, number one, there's just a general lack of understanding of what homomorphic encryption is, because again, like in Korea, like the laws are very conservative, and so you have to really go out of your way to convince them. And if a new person comes in, takes the job, and you have to do that cycle again, trying to educate that person about, hey, this is actually safe. And so there's that aspect. But more importantly, all of this still hinges upon actually having secure key management. And again, that's not really solved by homomorphic encryption at all. Again, right? There's a whole wealth of other stuff around that with just that you have to work around. And so there's different levels of certification that sort of deal with that. And obviously, there's a number of different cloud service providers that have been in this space and done secure key management for a while. So like leveraging that, I think, has been sort of our approach to getting a better response from regulators. Yep.
Thank you.
Thank you very much, and thanks again, the speaker.
Thank you.